In this video, I'm going to demonstrate how to implement a priority queue in a Java program. This is part of the Java collections framework. And what I'm actually going to do is I already have a program where I've implemented a queue in a previous video. And most queues operate on a first in, first out basis. So we add to the tail, we remove from the head just like so. There's no priority in a normal queue. It's just the first one in is the first one that's removed. But sometimes we do want to have priority. And the example that I often think of here is airlines and the different frequent flyer statuses that they have. So if there are seats available in first class, they'll typically go first to the top tier frequent flyers. And then if there are more seats left over, they go to the next tier frequent flyers and so on and so forth until they're out of seats in first class. So that's a good example of a priority queue, and it's what I'm going to model here. So with a priority queue, items don't necessarily leave the queue in the order in which they were added, but they leave the queue in a priority relative to other items on the queue. And you see that a priority queue will typically take the lowest number first if we're using numbers for comparison. Now you notice that this is not ordered as you might think, but if you go back and look at this animation, you'll also notice that we were adding items to the queue, to the priority queue, and removing items from the priority queue simultaneously. So when it's removing items from the priority queue, it's just comparing among the other items that are in that priority queue at that specific moment, and other items might be added later. So when we talk about that comparison, what we need to do is we need to consider an object's natural ordering, and that's how an object compares to another object, which one's greater, which one's less. And we can implement that by adding an interface called comparable. And comparable has a method called compareTo. CompareTo will return an int, and compareTo is comparing two different objects. Typically, the object that implements the compareTo interface and another object of the same type. If these two objects are equal, then it will return 0. Think about two different strings, one Smith with a capital S, the other Smith with a capital S. Those two are essentially equal, so that would return 0. Now, it will return a negative number if the object that we are in is less than the object we're comparing ourselves to. And it will return a positive number the other way around. So if the object we're in is greater than the object being compared. Now, this can get a little bit confusing, but the important thing to remember is with a priority queue, we're typically taking the smallest item off first. So the one, if we have a whole collection of objects and we do compareTo, the one that returns the lowest number, essentially, is the one that gets pulled off first. It's hard to explain and hard to understand, but it'll be easier to visualize when I continue to implement this implementation and then demonstrate it to you. Under the covers, the priority queue is a very efficient storage mechanism because it offers O log n performance for in-queuing or adding to the queue, and also dequeuing or removing from a queue. Now, O log n is kind of like taking an exponential curve and flipping it 45 degrees. You see what happens is as the number of items stored in the queue grows, the time to process it also increases, but it increases at a decreasing rate. So you can see this is a base 2 logarithmic curve where the first couple items are kind of expensive as we add them. But as we add more and more items, this curve flattens out. Now, that's an interesting phenomena that's related to something called a heap, or also could be in a binary tree or a sorted tree. The priority queue is a heap implementation. In other words, it's a heap under the covers. And I have a separate video that describes why heaps give us this logarithmic curve. If you're curious, I encourage you to check that out. The video is called Big O Math Logarithms, Heap, Binary Tree, and Computing Explained with Simple Live Example. Now, one other thing I need to introduce here that I know is going to come up is a static initializer. So remember that a static variable does not belong to an object instance. It belongs to the entire class. And that's efficient if we only need one variable for all objects. The example I gave earlier is a warranty number. For all Toyotas, the number you call for warranty service is the same. So we don't need to store that in every Toyota object. We can just store it once for all Toyotas, and that's effectively a static. Now, if we need to initialize static variables, then what we can do is a static initialization block, which is a lot like a constructor, but it's specific for statics. We just use the word static, open curly, and close curly. By the way, statics are not needed for priority queue in general. But in working through this example, I realized I was going to come across a static initializer, and just for the way that I'm implementing this, and so I wanted to take a quick moment and explain that. Now, with that explained, let's jump right in. We'll start with our existing program, and we have this buyer reader, which is reading in this text file of buyers. And notice that we have a priority loyalty level, if you want, at the end of each of these records. So platinum would be the highest priority level, then gold, then silver. We could add diamond or titanium or whatever we want, but this will give us a good enough sample size. So what we want the priority queue to do is return the platinums first, and then the golds, and then the silvers. But notice that the data coming in is coming in random order. It's not coming in with platinums first. So we're going to count on the priority queue to put these in the correct order when we remove them. Okay, so on the buyer reader, it's actually, the change here is quite simple. All we need to do is change the object type. Because what's the variable type? The variable type is Q, and Q is an interface. And what do we know about dependency inversion in Java? It means that variables should be interface type, and the objects should be a class that implements that interface. Variables could also be an abstract class type, but that's the principle of dependency inversion in Solid. And here's where we get to see a bit of payoff. Because take a look at this. Do you see this variable buyers is used in our application? And it's of type Q. And linked list implements Q. Well, guess what else implements Q? Priority queue. So if we want to change our implementation from a normal first in, first out queue to a priority queue, all we need to do is change this object type here, and the rest of our program does not need to change because we're referring to that common interface, hence the value of dependency inversion. So that's the easy part. Now, the trick is that a priority queue relies on an object's natural ordering to determine which one to come off first. And as I said earlier, it's the lowest number that comes off first. So next, we need to define what our object's natural ordering is. And this gets a little more tricky. Now, the objects that are in the queue are what? They are buyers. So if we go to buyer, what we can do to implement a natural ordering is say implements comparable. Now, notice it redlines because comparable is an interface. So if I Alt-Enter, it's going to tell me to implement methods. And there we go. We see that it gives us this method compareTo. So now we need some way to compare a diamond to a platinum to a gold, so on and so forth. And how do we want to do that? I mean, we can't really compare the strings because the number of letters doesn't matter. But we as humans know that, well, platinum is more rare than gold, and gold is more rare than silver, and you could say diamond more rare than platinum. I don't know if that's really true or not, but nonetheless, we know that as humans, but we need to tell the computer that. So we need to associate a priority number with each of these status levels. Now, when I say associate, does the word map come into your head? Maybe even hash map. So you see, we can define a hash map, and we're going to make that static, which says that a platinum is a 1, a gold is a 2, a silver is a 3, all right, so I think I missed one there. So diamond might be even higher than that. But the idea is that the highest priority is the lowest number because that's what our priority queue is going to use to determine what to pop off first. So I'm going to go into buyer and make a static map. Notice a couple interesting things here. The generic identifiers are string for the key and integer for the value, where a lot of times we see that the other way around. Well, the reason here is that we want to take the known strings, diamond, platinum, gold, silver, and relate them to a number. Now, the other thing is, notice I've spelled out integer with a capital I, which is the class that represents an integer. That's because a hash map can't take a primitive like an int. But the good thing is that Java knows how to convert an int to an integer and vice versa. So that will make our job a little bit easier. Now, why is this static? Well, this one comparison is going to be true for all buyer objects, and that's an ideal case for a static. So let's use a static initializer to initialize this priorities collection, because we only need to initialize it once for each object. We could maybe initialize it for every object in the constructor, but that would be a waste of memory. These priorities are going to be the same for all buyers. We just need to take the buyer's status level and find the corresponding number. And now we can use this priorities map in our compareTo. Now, this is maybe just a little bit tricky, so let me explain it. Remember, priorities is that static map that we've just put together. We are currently in a method called compareTo, which is not static. That means that we are looking at a specific object right now. And when we invoke getPriority, we're getting the string priority that relates to this object. A couple other ways we could do it. We could do this.getPriority, if that makes that a bit more clear so that you know we're referring to our current object. We could also just put in the priority attribute directly because we are within this object, so we have direct access to private member variables. But the most common way to do it is just to invoke the getPriority method as I had earlier. Now what's their priority? Well, what's happening here is our PriorityQueue is looking at all the objects it has and comparing them to each other. So the O that's coming in is some other buyer that we read from our list. We don't know who it is, we just know it's some other buyer. And we can ask that other buyer for its priority, which again is going to be a string, diamond, platinum, gold, or silver. And we can go back to this priorities map to find out what number that priority corresponds to. And then finally, we take our priority and subtract from that their priority. Now you have to think about this one for a minute, because remember, the smaller the number, the higher priority it is, okay? So let's say that we're diamond, that means we're a 1. Let's say we're being compared to a gold that's, I think, a 3. So 1 minus 3 is negative 2. And by returning a negative value, we're saying that we are less than the object that we're getting compared to, which might be a little bit confusing because you'd think the higher priority would be more, right? But there again, remember how priority queues work. The smaller number is what gets picked off first. So that's why when I did our priorities, diamond is 1 and so on and so forth. And actually, you know, that does kind of make sense. Because if you think priority number 1, that's the top priority, right? Which is higher than priority number 2, which is higher than priority number 3. So that does kind of make sense. So effectively what we're saying down here is, if we are high priority, we're going to be a low number. And if what we're being compared to is a lower priority, it's going to be a higher number. So our priority minus that priority will return a negative number, which puts us to the top of our priority queue. I can keep talking. It probably won't make any more sense than it does right now. So I hope that there's a bit of a nugget there that you can think about. So at this point, let's see what happens. And remember, just a quick note before I do it, just kind of take a mental screen capture of what we have here. So the highest priority we have here is Michelle Spratt and Checkers Jenkins. The next priority is Brandon Jones, and then Bugsy Smith and Betty White. So I anticipate when I make my vehicles, I'm going to see Michelle Spratt and Checkers Jenkins as the first 2 qualified buyers, then Brandon Jones, then Bugsy and Betty. Let's take a look. Now we know it's going to pick a buyer when I choose something from this make model dropdown. So if I go to Prius, what do we see? We see Michelle Spratt, and Michelle Spratt is platinum. So let's go ahead and add some information for Michelle's Prius. And then save. And in a previous video, I'll show you how I did this. In a previous video, what I did is when we first look at a user, we do a peek operation, which simply looks at the item on the top of the queue, but does not remove it. Then when that happens, that's triggered when I pick from that drop-down, that combo box. When we actually associate a user with a vehicle, we do a pull operation, which then removes that user from the head of our queue. So that's why it's kind of a 2-step operation. So when I first choose from the drop-down, it just peeks at the next item that's on that queue, and I can keep peeking at that, and that's not going to change, right? But when I save is when it actually pulls that item off of the queue, and then the next object on the queue becomes the next highest priority item that's going to get removed. So you notice for my first vehicle, it was Michelle Spratt. And now for this vehicle, it is Checkers Jenkins. And let's just confirm, look at that, Checkers Jenkins is platinum. Our priority queue is working as we expect. So I make a vehicle for Checkers. And as soon as I hit save, we're going to do that pull operation and remove Checkers from the queue. And now my next item, because I've now satisfied my 2 platinums, Michelle Spratt and Checkers Jenkins, my next vehicle should go to Brandon Jones, who's our only gold. And sure enough, there's Brandon Jones. Fill out some details here. And next item will either be Bugsy Smith or Betty White, probably Bugsy Smith. And there's Bugsy Smith, as we see. Let me set a few breakpoints and run this in the debugger so that we can watch it at our own pace. I did do a breakpoint through this buyer class in a previous video, so I'm not going to worry about that for the sake of time. I'll point you to the video where I initially implemented a queue if you're curious how that works. The only thing that's new in this video, well, not the only thing, but the thing that is new is what I want to debug through. So I'm going to snap a breakpoint in this compareTo, which is actually going to get called fairly frequently. I'm also going to snap a breakpoint in this static initializer, and let's go ahead and debug. First thing, before the screen even renders, is it does the static initialization of our priority map, mapping our strings to priority numbers. And really, I could pull this out and put it into a different class, but okay, this works for me. I'm okay with it being static because I know I'm repeating myself here, but there's only one priorities variable no matter how many objects we have. So that's more efficient than having an object instance variable where we would have one variable for each object. So I'm good with that at this moment at least. Now we're doing our compareTo, and notice that the screen has not rendered yet. So I'm going to walk through this compareTo and note that this compareTo is happening. This is really interesting. Notice when the compareTo is happening, it's happening when we are offering the item to the priority queue. So you see the priority queue is already putting this in order as we're adding items to it. And I can continue and continue, and you'll actually notice it takes a few more times, and then finally our form renders. And now we can continue as we did before. Breakpoint hits when I choose the dropdown. And this is actually a breakpoint I set earlier to choose the next qualified buyer when we select from that drop-down. I'll go ahead and turn off these breakpoints here where I have the peak and the pull. That again, those I showed in the previous video. So we see no surprise here. First buyer is Michelle Spratt, and remove a couple of other breakpoints that I have here, but nonetheless, now the priority queue is saying, okay, my head's gone. I need to pick a new head. So let me take a look at the objects that I have, and I can pick that new head. And it's doing several comparisons among several objects, and then it basically says, okay, this is the next highest priority item. We create another new vehicle, and I'm anticipating that Checkers Jenkins, who was our other platinum, I believe it was, will be selected for this vehicle. And sure enough, there we go, Checkers Jenkins. I hit save. It's going to now, once again, see that the head has been removed from the priority queue, and it's going to go through this compareTo of the remaining objects to see who's the next lowest value that's going to be the new head on the queue. Since our 2 platinums have been satisfied, the next head will likely be me, Brandon Jones. And sure enough, there I am, Brandon Jones. So I could keep going, and we'll see we'll eventually exhaust this queue. But you see that with the priority queue, items are pulled off the queue not in the order in which they were added, but in an order of priority where the smallest number is considered the highest priority. And then once the item is pulled off the queue, the priority queue goes back and recalculates who the next lowest item is and makes that the new head. Lather, rinse, repeat. Really interesting concept and a very useful one, I think, as well. So as always, I hope this video was extraordinarily helpful, and I look forward to reading your comments. Thank you.